When a quadrilateral is inscribed in a circle, we know that opposite angles are going to be supplementary, meaning they add up to 180 degrees. So in this case, I can find x because I know that 80 degrees plus x has to equal 180. So x must be 100 degrees because 100 plus 80 is 180. Okay? Because both opposite angles are supplementary, I can do the same to find y. I have to think, what would I add to 75 to make 180? Well, that's going to be 105 degrees. So there's a very simple example. Let's take a look at a couple more that are slightly more complicated. So once again, we can use the fact that if I have an inscribed quadrilateral, meaning all the vertices touch the circle in the four-sided figure, opposite angles are supplementary. So those two angles need to add up to 180 degrees. So it's a bit more complicated this time, but nothing too bad. Those angles have to add up to 180, so I'll use that to write my equation. Adding like terms gets me 18x equal to 180. And then dividing both sides by 18, I find out that x is 10. Okay, I'll do something very, very similar to find my other variable as well. Opposite angles are supplementary, so those two angles that are across from each other also need to add up to 180. So my equation would be c plus, I don't need the parentheses because I'm just adding, so I'll drop the parentheses off, 2c minus 6 also has to equal 180. So let's combine some like terms. I've got 3c. I'll also add 6 at the same time just to save a little bit of time. So 3c equals 186. Dividing both sides by 3 gets me a c value of 62. I want to take a look at one more example that's definitely much trickier. This example not only uses the fact that opposite angles are supplementary, as we just talked about, but it combines the idea of an inscribed angle that we looked at in a previous video. For example, in this case, let's start with finding, I guess angle x, or variable x. So I know that opposite angles are supplementary. However, this time I don't know angle A, I don't know its opposite, so I don't know what to add this up to, so it seems like all hope is lost. But here's the trick. What I want to do is I'm going to extend the rays out from point A so I can kind of see that inscribed angle a little bit better. Recall that an inscribed angle is half of the arc it intercepts. I can take a look and I see that I can find out that entire arc because that entire arc is going to be the sum of those two pieces right there. Adding those two pieces together, I find out that that entire arc is 232 degrees. Since we know from the previous video that the angle the inscribed angle that intercepts that arc is half of this, I can divide that by 2 to find out that angle A is 116 degrees. So now I can go ahead and use the fact that opposite angles are supplementary. But without using that inscribed angle, this problem would be impossible to do. So let's go ahead and write our equation now. Now it's not bad at all to solve. 4x plus 116 has to be equal to 180. If I subtract 116 from both sides, I get 4x is equal to 64. And then dividing both sides by 4, I find out that x is equal to 16. Okay, we'll need to do a similar thing to find y. So let me switch colors. Let's go to red, I suppose. I know that 7y and angle B are going to be supplementary. However, this time I don't know what angle B is. So I'm going to do the same thing. I'm going to kind of extend those sides out so I can see the intercepted arc a little bit better. So I can see that the arc it intercepts goes from A all the way around to C. Adding those two pieces together, I find out that that's 164 degrees. And since the inscribed angle is half the arc it intercepts, I know that angle B must be 82 degrees. Okay, I can't do this problem if I hadn't done that first. So adding those together, since I know opposite angles are supplementary, now it's not bad. 7y plus 82 has to equal 180. Subtracting 82 from both sides, I get 7y is equal to 98. And finally, dividing both sides by 7, I find that y is equal to 14.